Hello all, welcome to Genius channel. We are going to see some previous year MBA maths questions. Okay, so all of you see the question number 79. Question number 79. So that is a question from integration. All of you read the question. What is integral 0 to pi e raised to x sin x dx equal to? What is integral 0 to pi e raised to x sin x dx equal to? Try all of you. Which method you will apply here? There is a product, isn't it? First function and second function. Or you take in the chain, when e raised to is coming, that will be taken as the first function. This is second function, first function. So here a product is coming. So we can apply integration by parts. What is integration by parts? First function into integral of the second function. Integral of the second function minus integral of derivative of the first function, isn't it? Into integral of the second function into integral of the second function dx, isn't it? Okay, and within the limit 0 to pi. Okay. Next, just apply the limit. Just apply the limit of it. So here, when you apply pi, sin pi is 0. So this term will become 0. Then if we apply sin 0, that term again becomes 0. Minus, apply the limit to this one. Okay, we need to integrate again, isn't it? Okay, so just keep like that. Now we have integral of, only we have integral for this one, that is integral cos x e raised to x dx, isn't it? Integral 0 to pi cos x e raised to x dx. Okay. Now apply parts here. For this section, apply parts. So we have a negative over here, 0 minus something. So a negative is there. Then integrate first function into integral of the second function. Integral of the second function minus integral of derivative of the first function into integral of the second function dx. So this will become positive here. Okay, so that will become minus e raised, so there is a limit 0 to pi. Minus e raised to x cos x is here, minus e raised to x sin x dx, 0 to pi is here, isn't it? Now apply the limit here. Apply the limit here. So this will become cos 0, isn't it? So there will be a isn't it? You have to apply the limit. First function into integral of the second function minus second function into integral of the first function. Yeah. So here I am going to apply the limit for 0 to pi here. This I am leaving as such. Now listen. Now listen. See what is this thing? That is our question itself, isn't it? Integral 0 to pi raised to x sin x dx. So I am taking the question as I. I is equal to integral 0 to pi raised to x sin x. I is the question. So I can replace this as I itself. So I have minus e raised to x cos x 0 to pi minus this thing, no? This thing in there thing is I minus I. So I is equal to this first thing we'll get. Now I'm writing here. I have I is equal to, apply the limit here. We apply the limit. When you apply the limit, e raised to pi minus e raised to pi cos pi. What is cos pi? that is -1 minus e raised to 0, no, minus e raised to 0, that is 1 minus 1, then cos 0 is cos t1. Okay, so what will get? Then minus 1 I is there. So this will become e raised to pi plus 1, e raised to pi plus 1 minus I. So I is equal to e raised to pi plus 1 minus I. Take I to this side. So 2I is equal to e raised to pi plus 1. So what you get? We have to find 2I. So this is I. So I is equal to e raised to pi plus 1 by 2. E raised to pi plus 1 by 2 option. E raised to pi plus 1 by 2 option. So when you have a product, there is no other method. You can do integration by parts. Okay. Just copy down this. Any doubts? Please comment. Those who are studying integration for the first time, you may feel this as little bit tough, but don't worry. Practice and practice. It should be easy. Okay, so let's go to the next question. Question number 80. Question number 80. If f of x is equal to x square minus 9 by x square minus 2x minus 3, x not equal to 3 is continuous and x equal to 3, then which one of the following is correct? Which one of the following is correct? Okay, all of you try. This is given that it is continuous at x equal to 3. Which one of the following is correct? So just apply the limit. They are saying that it is continuous at x equal to 3. So just apply the limit f of 3 is equal to limit x tends to 3, x square minus 9 by x square minus 2x minus 3. Isn't it? Good. So this will become 2x by, this will become x square, on applying the limit, that is 2x minus 2, isn't it? Just taking the derivative, limit x tends to 3. Now what does this become? Put x equal to 3, you apply the limit, so 2 into 3 by 2 into 3 minus 2. So that is 6 by 4, isn't it? That is 1.5. You get 1.5. So f of 3 is equal to 1.5. F of 3 is equal to 1.5. Very easy question, direct one. Okay. So moving to the next question. Question number 81. What is integral 1 to e x ln x dx equal to? Question number 81. All of you try. Integral 1 to e x ln x dx equal to. So here also we can apply integration by parts, isn't it? Why? Because here we are having two functions and the product is there. So obviously we have to apply the integration by parts. So I'm taking this as the first function, this as the second function. So first function into. So this is actually log x, isn't it? So first function, log function, first function into integral of the second function minus integral of derivative of the first function into integral of the second function dx, and this everything within the limit 1 to e. So this will become x square by 2 log x. So I'm separately giving the limit for this, minus here I have again integration. I have again integration, that is integral x by 2 dx, isn't it? Direct one, no? Very easy. So just apply here the limit. So this is log x square by 2 log e, log to the base e, log e, what is log e? That is 1 minus 1 by 2 log 1, that is 0, minus here I have 1 by 2. This is in the, here it is 1 to e, integration is from 1 to e. Okay. So this is a 1 by 2, x integration of x is x square by 2. So x square by 2, again the 2 is coming, so x square 1 to e. So this is e square by 2 minus, this will become 1 by 4 e square minus 1 by 4 e square minus 1. So that is e square by 2 minus e square by 4 plus 1 by 4. So you will get it as, just cross multiply, you will get it as 2e square minus e square plus 1 by 4. So that is e square plus 1 by 4. E square plus 1 by 4, option B. E square plus 1 by 4. Just direct application of integration by parts. Nothing else is there. Very easy. Go through this. Okay, so go to the next question. Question number 82. Question number 82. What is integral 0 to root 2 x square dx equal to? Where, so this is not x square, yeah, x square is there, but we have a square bracket here, isn't it? So what is that square bracket? That is greatest integer function. Remember, greatest integer function we are studying in 11th standard. So this square bracket means it is greatest integer function. Okay. So read it. Try to do what is integral 0 to root 2 x square dx. That is within the greatest integer function. So what I'm going to do is I'm going to split this integration as 2. That is 0 to 1 x square dx plus 1 to root 2 x square in the greatest integer function x square dx. Now our function is x square, isn't it? Our function is x square. And before 1, which is a square that is coming, the limit is 1, isn't it? It is up to 1 only. So which is the integer that is coming just before 1? That is 0. So this entire thing will go as 0 because the function itself becomes 0. Why? Because within the limit 1, just before 1, we have 0 as the greatest integer. Then coming to the second part, before root 2, which is the greatest integer function, that is 1, isn't it? So integral 1 to root 2 1 dx. So that is 0 plus what is the integral of 1? That is x within the limit 1 to root 2. So that is root 2 minus 1. Root 2 minus 1, which is the option A. Option. Understood? So just understand what is greatest integer function. Greatest integer function means if the limit is given 0 to 1. If this is the limit, which is the number that is coming just before that, which is the number which is not just the number, which is the integer that is coming just before that. Okay, so before root 2, the integer coming is 1 only. Before 1, the integer coming is 0. Okay. Go to the next question, question number 83. What is the maximum value of 16? What is the maximum value of 16 sin theta minus 12 sin square theta? 16 sin theta minus 12 sin square theta. Maximum value you have to find out. So I'm just taking something common here. I'm taking just 12 common here. So this will become sin theta I'm just taking 12 common here. Minus 12 I'm taking common. So this will become sin square theta minus 16 by 12 sin theta. Isn't it? Okay. So I'm just doing a rearrangement here. I'm going to write this entire thing as negative 12 into sin theta minus 2 by 3 the whole square minus 4 by 9. 4 by 9. So here I'm just applying the completing the square method. See here I'll get a 4 by 3. Here I'll get a, if I cutting first table, yeah, first table I'll get a 4 by 3. Then I'm 4 by 3, isn't it? 4 by 3, 4 by 3 sin theta. So see a plus b the whole square is equal to a square plus 2ab plus b square. So here a minus b. Here I'm applying minus because here minus is there, no? So a square minus 2ab plus b square. See this minus 2ab, that minus 2ab, that 2ab thing now, that is this 4 by 3 sin theta. 2ab is 4 by 3 sine theta. So that means I can take as A as sine theta, B as 2 by 3. A as sine theta, B as 2 by 3. Okay, then I'm adding and subtracting 2 by 3 square. Then I'm just completing the square method. So this will become A minus B the whole square. Understood? Now just open the bracket. So this will become minus 12 sine theta minus 2 by 3 the whole square plus 16 by 3 plus 16 by 3. So what could be the maximum value of this function? Our function is this much. What would be the maximum value of this function? Maximum value of this function is 16 by 3. 16 by 3. So answer is option C, 16 by 3. Option C, 16 by 3. Okay. So just go through. We'll do the remaining question video. Thanks for watching Genius channel. Love you. Thank you.